Law 5 has led us to Law 6. Law 5 is a negative power law. Law 6 becomes the fractional law. The fractional law. The fractional law. Okay? The fractional law. And in this law, what are we talking about? Look up here, where you have instances as a raised to the power of m over n. Okay? That gives us, be careful, a, this power here takes up the root. Okay? N becomes the root, while m retains its power position. N becomes the root. For the denominator of the power becomes the root, while the numerator of the power becomes, alright, still retain its power. That's the first aspect of the law. The second aspect of the law, okay, you have a, beg your pardon, a over b raised to the power of m over n. The same thing applies, okay? The root becomes our n, while the n becomes the power. Did you get that? As simple as that. M still retains the power, but n becomes the root of whatever is in the bracket. Did you get that? Okay, let's have our revision examples. Revision questions. Alright. Okay, the first revision question. We'll pick our first revision question from this. Okay, this unsolved question. Here we have 3 raised to the power 3, 4. Okay, minus half. Then we have 0.125. Then we have, okay, 16 over 81. Alright, minus 3 over 4. Alright, then we have the fourth one, which is 27 raised to the power minus 2 over 3. Okay, let's take this for now. Alright, subsequent questions will be given to you. Let's see. Solutions. Okay, I'm glad we've done it to an extent, so there is no cause for alarm. 3 over 4, okay, raised to the power of minus half. The first thing is to remove your negative sign by introducing a reciprocal. Okay, did you see that? Alright, then, or thereafter, we apply this law. Did you see it here? Okay, so from here, 2 becomes the root, and 1 becomes the power. As simple as that. You have 4 over 3. Roots, okay, 2. Okay, now when you have 2 as a root, it's called the square root. Square root, all right? That means you have to square root every number in this bracket, okay? From here, the square root of 4, square root of 4, square root of 4, 2. Thank you, all right? To know squares and square roots, check our series, okay? Division series. I've dealt with it. Okay, so that square root of 4 is 2, but square root of 3 should be 1 point, and decimals, but you don't need to write decimals here. So what you need to do is just to put it back in roots. Okay, all raised to the power of 1. And finally, I lost that 1 to each of them. 2 raised to the power of 1 gives you 2, then this gives you root 3, because that one is insignificant. All right, did you get that? Roots, and you apply gently. Can we move on to the next question? Okay, the second question, 0.125 raised to the power of 1 over 3. Okay, now look at this. It's the same question we have here. So let's just go straight to our solution there. We said 125 over 1000. All right. minus 1 over 3. And here we have 1000 over 125. Okay, raised to the power of 1/3. Okay, I hope you can get it. Now, what do we do here? Because that's where we stop in the fifth law. What do we do here? The same thing. The same thing applies. Okay, so just introduce your what? Your roots. Thank you. In this case, our root will be what? 3. 3 and 1,125. Alright. Raised to the power of 1. 1 remains the power. Okay. Alright. Equals to. There we have cube roots. When you see 3 as the root of a number, it is called cube roots. Also check our series, okay, on cube roots. So from here, cube root of 1000 is 10. That is 10 times 10 times 10 give us 1000. Just pick one. 10. Alright. Over cube root of 125 is what? 5. Good. 5 times 5 times 5 gives you 125. So just pick one. Raised to power 1. Alright. 10 raised to power 1 is 10. 5 raised to power 1 is 5. You don't stop there. Simplify completely. 10 divided by 5, 2. Alright. So in essence, the whole of this gives us 2. That's mathematics for you. Let's move on. In the third question, we have 16 over 81 into brackets minus 3 over 4. Did you see this? Okay. We have solved it to a particular point in the third law. Okay, here. So you don't need to waste your time. Just use the law. Reciprocal. 16. 3 over 4. Okay, so here we go. The same thing applies. This law. Very interesting law. Alright. 81, 16. What's root here? You said 2. No. It can be 3. No. What? 4. Yes. Remember we said the denominator becomes the root. The denominator of the power becomes the root, while the numerator retains its position as the power. Okay, so here we have 4 and power 3. Alright, so you look for numbers and you can multiply in 4 places. That gives you 81. And it gets 2 times 2 times 2 times 2. Gives us 2 times 2, 4 times 2, 8 times 2, 16. So it can be 2. Then let's try 3. 3 times 3, 9. 9 times 3, 27 times 3, 81. So that's 80. That's 3. 3. That means 3. 4 times gives us 81. Then of course, for 16, 2. Oh, wonderful. So 2 brackets power 3. Then here we can do justice to this. You can say, using your power law, thank you. So over 2 raised to the power of 3. Okay, that's 3 raised to the power of 3. 3 times 3 times 3 gives us 27. Okay, over 2 raised to the power of 3. 2 times 2 times 2 gives us 8. Expressed as mixed fraction. 8 in 27. That's 3 times. Okay, remainder 3. So remain 3 over 8. You can cross check. 3 times 8 is 24 plus 3, 27. Alright, but if you don't still understand how to convert from improper fraction to mixed fraction, you can check our division series on fractions. It is well explained. Okay, and the fourth one, we have 27. Yes, I guess you should have solved this yourself. But let's do it together now. That's 27 over 1 as a fraction first, 2 over 3, negative. Fraction first, thereafter becomes 1 over 27. Okay, what has transpired? This minus sign has been eliminated due to the reciprocal of the number. Okay, so we have introduced this law, fractional law. Your roots 3. 1 over 27. Then what will be our power? 2 root. 2 power 3 roots. And that gives us a Okay? Cube root of 1. 1 times 1 times 1. That's 1. So 1. 1 in 3 places. Cube root of 27. That's 3. R is above 2. And in the power, remember that each of them has access to 2. That's 1 raised above 2. 3 raised above 2. Gives us 1 over 9. Alright, and this gives us the final solution to the last revision question. Okay, I hope you get this very well.